Am I live chat? Test, test, test. Test, test, test. All right, we're live chat. We're live. All right, chat. We're gonna be making a compiler. Not, we're gonna be working on a compiler that I've already been working on. Um, I've been working on it for a few months. It's in C++. All right. So let's get started. Actually, let me turn this off real quick. Let me close some stuff to make sure I'm not doxing myself. Low key, I want to go live on Kick, but like I can't play music on YouTube. So they won't let me because they're rude. They're rude people. Okay. And let me pull up the LVM documentation. All right, it's been 3 months since I last worked on my compiler, so I gotta get familiar with it again. So let's see. All right, let's get to work. Let's get to work. So let me turn on this. All right. Boom. Boom. All right. All right, so it's been a little. So let me see. So right now I'm in the process of making if statements for my programming language. As we see here in the to-do, we have. Last I worked on this was in October. Like I grinded hella in October and then I just stopped. Now it's January. So we're gonna have to add a few things. So we're gonna have to fix parse term and parse factor. Apparently there's completely useless code in there. We have to add this. I'm pretty sure okay, we got a lot of shit to do. But let's see. So I don't know really where I left off. I know I was in the generator. I was doing a lot of work here. So, it's such a mess. It is such a mess, guys. So if I remember correctly, let's just run a few tests. All right. So let's do I have a build directory? I don't. So let's just make this real quick. Is that good? Let's see if there's any errors at first, and then if there is, we'll. Okay. So I was competent enough to not push bad code. All right. So let's go here. My setup's a little janky right now. I'm not using I'm not opening that. I'm not using Linux, so I have to use WSL. But all right, let's test some stuff first. Test.xd. So we're gonna do let int x equal 10. We're gonna just do some stuff here. Let float. I forgot what types I have in my language. Let's see. I'm pretty sure that'd be in my parser definition. I forgot what types I have. So I have an int, I have a float, and that's it. And I have an identifier. So this is the only type. Like, that's not even technically a type. So I only have an integer type and a float type. So this is definitely gonna be difficult. Integer and a float type. All right, so let's just do some stuff. So let's do fn int main let x equal 10 or int x equal. So this is kind of like my syntax for the language. It's kind of like Rust, but I'm trying to make a C kind of language. So first I kind of have like integers. I need to add chars. We're gonna have floats. Chars are gonna be really difficult because if I remember correctly, we kind of have to store it in the program's I don't even know what it's called. Like this, I don't even know. It's not on the stack. It's somewhere else in the program memory, technically. I think it's in I don't even know. So I'm gonna say let int y equal 5, and then I forgot like how much I added to my language. So we're gonna let z int z equal. So I do remember I did add parenthesis support for like expressions, like binary expressions. Yeah. So I did add. Let's do x times 2 plus y. All right. So let's run this. Okay, so I believe this would work. So we do have these errors though. I do remember this. All right, so a few things I want to try and fix is fixing the source file name, which should be fairly simple. I just have to pass an argument to my generator. I don't know. Let's see. Let me make sure this is right. Okay, so we have an int 10. So we store 10 in x. We store 5 in y, and then we multiply 0 and 2, and then we load 2 into y, and then we add %1, which is the result of that, and then we store that in z, and then we return. Also, I think I did add return, actually. Did I? Let's see. No, I guess that doesn't exist. Okay, so we're not gonna do returns yet because that just doesn't make sense for right now. We already have functions. We're gonna try and add if statements. I still have to familiarize myself with my own compiler because it's been 3 months since I've worked on this project. So it's been forever since I even touched LLVM documentation. I know we need the IR builder class. I know we need a few other things. So let's go to. We're gonna need IR builder, which is this. So we're gonna be going into heavy LLVM documentation. Yeah, we're gonna need to do. We need where is it? We're also gonna be doing LLVM type a lot. We're gonna be using this because LLVM's so weird with this, dude. It's like so annoying. This isn't the right thing though. Is it builder base? Create. Okay, it is. So this is like what we're gonna be using most of the time. This is like the class that we're gonna be using. It's IR builder. I believe it should be defined already. My code is pretty dirty right now. So let me just familiarize myself with it real quick. Left type. Okay, so let me make sure. So this is our global values, our named values. These are our local variables. I feel like if I turn the whole constructor into a class, I could low-key put these as private members. I might do that too. Let me see. Okay, so gen expression. So we are using a visitor pattern here. Let me see. Generate.gen expression, bin expression, left-hand side. Gen expression. Okay, so then we call it this. So then this is going to gen the primary expression. So what does the primary expression do? Okay, so this is what we're going to be working on too. So this returns an LLVM value. Let me just review my code. Gen expression. Okay. Oh, yeah. So we already kind of added the. we already kind of added the like base for what we need to do. I believe I already have like my Lexer already has, yeah. So we already have if statement like stuff going on, but we need to work on this. This is so basically, if statements are just like I have them defined as a conditional expression, which is here a conditional expression. So we just have a type, which is basically a conditional op type. So that'd be like less than or equal to, not equal to, that kind of stuff. And then we have a left hand side and a right hand side. I don't know if I should be using structs here or I should be using classes, but honestly, who cares? Okay. So I think I know. I just have to kind of like look at it first. Sorry, guys. Let me make sure builder. Yeah, so our IR builder should be defined somewhere over here. Yeah. So this is our IR builder. Also, one of the other hard things is like this insert. This is hard as hell to make, but it's whatever. So we're gonna have to scroll here. It's gonna be like one of these. Yeah, so here. So create I think it's create condition. I think it's this. Create conditional it's not BR though. I think it's gonna be, yeah, it's gonna be here. Where is it? I just saw it. Create load. Okay, I think it's this. It's a compare. So for if statements, we're gonna have to be using this a lot. Let me just see if this compiles though. Let's just say if x is equal to y. We're gonna do no. I don't think I have support for comments yet. Oh, that does work. What? How does that work though? Did I just add this and I just totally forgot? I don't have a log, so I really don't remember where I left off. So this is like what not to do when you're programming. Like I have zero clue. Like, okay, it's gonna be gen expression. Let me make sure. What even is an expression in my code? An expression could be a primary, binary, or conditional. Okay. Why don't I have like a log? I only have a to-do list. I don't have a log. I should probably make a log to where like I know where I left off at. Like exactly. Or I should just lock in and just finish my projects, but that's never the case. Hold on, chat. I'm getting a text. I've been doing a whole lot of nothing at the beginning. I promise you, if we get deeper into the stream, we're gonna be cooking. We are gonna be cooking. All right. All right. So let's see. So I don't. All right. Let me just recap. I'm just gonna explain how my compiler works because I need to like actually like lock in because I kind of forgot. I made a whole entire I made 2 compilers in my lifetime and I forgot how they work. But I also know like my code is like really bad. So we're gonna have to do something about that. It keeps recommending YouTube Studio. I'm not going to YouTube Studio, chat. All right. So I made this compiler completely from scratch. I kind of watched some tutorials, and I also copied crafting interpreters that I copied from kind of like their design from the website. But for the most part, it's my own. So let me just so here we have this is our main function. So our lexer is pretty simple. We basically read a file. We read a file into like a string or a buffer. So it's all into a string, right? And then we just iterate over the string, over the characters, until we reach spaces, right? So that's how we kind of like define it. So we ignore white space. So for this, we have two functions. We have peek and we have eat. Eat will return a character at a certain index, or no. It'll return a character at the current index we're at. And then peek, basically, given an offset. So like say, here, let me give you guys an example. I'm kind of like chatting out of my, all right. Let's say let int x equals 10, right? Basically peek, so our index kind of keeps track of like where we're at within like the characters. And then we just iterate through all the characters, right? So peek will allow you to peek with the offset. So if I was at L and I wanted to peek 1, or if I just called peek, it should be default like, let's see. The initial thing is 0. So we kind of check like, if we peeked once, it would be E, right? So, and then after that we eat. When you do eat, it'll return kind of a character at that index, right? I don't really know how to explain it. Eat just kind of like returns a character, right? Then our tokens. So our token is basically a struct. So we have a token type, and then it's just an optional value, right? It's a std optional value. All right, and then here are all our token types. So this is basically all we have in our programming language so far. So basically we have a vector of tokens, and then we just push back on those tokens, and then we return it. And then that gets handed to our parser, right? So I'm not going to really explain the whole too much, but I'm trying to recap for myself because it's been a while. So then we kind of iterate over the tokens here, but we parse it. The weird thing here is we don't, how do I explain this? This is our AST thing, right? And then the whole kind of like the root node of the AST is the program node, which is defined here. And where is our program node? Yeah. So it's just a list of statements, and then statements, it's kind of like going up. So a statement is a let statement, a function, an assignment, an if statement, and then so like what is a let statement? A let statement is you have a type, an identifier, which is the variable, and then an expression. And then if you go all the way up here, an expression could be just like a number. In our case, we don't have characters yet, so it'll just be either a number or float, as you can see here, or another expression, technically, or an identifier. And then we also have a binary operator expression, so that would be like 5 plus 2. That's how I define it. And then a conditional would be like if, like a equals equals, not equal. All right, so that's kind of what we have. I should low-key put this into like the same thing, like if I just had like op types. But I just want to be a little verbose. So this is just how we're gonna do it, right? All right. So then in our generator, we are using LLVM. This is like a bunch of bloat code. I'm going to try and just fix it up later. I'm not going to like do too much like crazy optimizations, right? We're just going to go over it. We're going to find the bad code. We're going to eliminate the bad code, and then we're good. Also, the reason why I'm using a visitor template or a visitor pattern is because our nodes. How do I explain this? It's a variance. It's a stood variance, right? And I guess there's like a better. I guess you could just switch based off the variant. Like there's a number within it, but this is using like the visitor template is just a lot easier, and it's a little more verbose. It looks ugly, but it's a little more verbose. All right. So that is primary expression visitor equals. Okay. Yeah. I honestly, it's like really. I hate C++ so much. I hate C++ with a passion. But whatever. So let's see. Let's see where I left off at. So I know I left off at gen expression. Okay, so I did make a create ICMP equal. Here's when Godbolt's gonna come in handy. Godbolt. Here's when it's gonna come in handy. Yeah, I was already like you can see here. Okay, so first, when we do it if. Let's just be a little more verbose. Let's let this compile. So first we store the value in X. I don't really like LV because these percents are supposed to be variable names, but it just puts them as numbers. So here, so we kind of break. And I'm having like this is what I remember struggling with. I don't remember like breaking because then you kind of have to set an insertion point. So the way LLVM works is they give you a builder, right? And this builder basically generates all your IR, right? So it's like that's given, right? So it actually generates all the values in the code and then it stores it for you. If you can see that right here. If we go here, so it stores it in the module. Let's see here. I'm trying to remember like everything. I'm sorry. It's like LLVM. It like hurts my head. Like, see, this is why I don't like C++. This is why I kind of hate it, because it's so abstract. Like, and you have to like go into the docs all the time. I guess I'm complaining. I guess it's like a skill issue. But like, also instead of doing errors, I kind of want to throw exceptions. But I guess this would make more sense. But let's address the elephant in the room first. So let's do this. Because I know there was a issue. So we're going to have to do some debugging. Whoops. Whoops. Why is this not working? Okay, there we go. So it just hangs. Why is this hanging? Oh, sorry. It's because my Lexer was hanging. Because I thought this was fn int. There we go. Okay. So we get these errors. Invalid operand for expression. I don't understand why though. Invalid operand for expression. So let me see here. So let me be like kind of like understand why this happens. So technically it's not this is in with invalid operand type for expression would be within this. No. Okay, so it's in within our binary expression. So it's saying invalid because it does, like, the type doesn't know, like, the type, it doesn't understand it. But it still works though, which is weird. Also, we have to add division. I don't have division in my. I think division was also kind of weird because you have to, like. It's really weird for division. Like, I didn't understand. So we have to. Let me add that too. Wow. 2026. What's the date? It was the 9th. 01-009. Add division for binary operations in the generator. Alright. Let's see. I don't know why it would say invalid operand type though. It doesn't really make sense. Unless there's like an error in my Lexer. Actually, so let's do a little debugging. Let's just print all our tokens out real quick, because I want to make sure. Let's just do this real quick. Alright, let me make sure everything looks good. Okay, so we have a fn int ident token, open paren, close paren, open bracket, let int x equal intlet semi, let int ident y equal intlet semi, let int ident equal open paren. Oh, open parenthesis y. Oh, I think here's the issue. Because it's not y intlet. Oh, so I think it is it's not lexing this properly. So let me check. It should. Token type mul. It should we should get a multiply token like right here, but it's not recognizing that. Right? Because we have ident, which is y. Like after the equal, it's open paren, and then it says intlit. It doesn't say multiply, but it should. What's the issue here? Is mul not like a real token? Let me check. Token type mul. Well, it should, but maybe it's like a off. Maybe I have like an off by winner here. So we peak one. What am I doing wrong? Open paren. Like it doesn't so like if I did this instead of all this crap, let's just make it if it's not recognizing my multiply token properly, it's gonna say just X. It's gonna do 2 identifier tokens. Yeah, see, so it doesn't recognize the mul for some reason, but I think would it recognize if it's this? No. What? Do I have to add maybe like a space? Huh. So it's not, unless I'm just not printing it. Is that the reason why? Am I just not? I think I think I just made up an error in my head because my logging isn't good. Maybe it is. Let's do this. Maybe it's just because I didn't have a case for that. That's kind of silly. Well, I guess it wouldn't generate completely, right? So it is okay. So it is working. That's weird. So why do we get that error? Because I would think like, okay, let's just see the output again. Because it still generates it, but it gives us an error, and I don't understand why. Now it just gives us 1. Invalid operand for invalid operand type for expression. What does that even mean? The types are the same. Oh, I think I know why. I think I know why. Let me see if I'm like silly or not. Left hand side get type. It still generates it though, which is it's very weird. And it looks like it's like the expected value. It still does the add operation, but it gives us an invalid. So why? Maybe because it doesn't break, but am I just not using the right C++ semantics? Hold on, chat. Let me. I don't wanna. Hold on. Let me check something. Am I smart or am I dumb? We're about to find out. I'm gonna use good old. I think it should be an if-else statement, guys. I don't think it should be else. I also should check for if it's null or not. Let's just see if this works then. Sorry guys, I'm not even showing this because it's like really awkward. But do I break? How do I break though? Is floating type so I break? Let me see. I should return as well. I think I understand because I wasn't returning. Let me just return after. Yeah, so I'm gonna just return after every statement and see if that helps. Oh, I'm not even like showing my screen. Hold on, guys. I think the reason why, I think I figured it out. The reason why was um, I wasn't returning after these if statements. So it would automatically go downwards and then it would just hit that else statement. Let's see. Was that the fix? No. Oh, my bad, guys, my bad. Rookie mistake, rookie mistake. Was it value and function return void? Oh. Sorry, guys. Yeah. Oops. Why is this not doing a semicolon? There we go. Let's see if this works. Hopefully it works. Did it? It did work. Okay. So I wasn't returning, so it would just like hit every condition statement, and then it would just like poop itself, because then it would reach here, and then be like, oh, this is invalid operand type. I also added this. All right, so now this doesn't really help, but that's like one bug fixed. Let me push those fixed gen expression fixed gen expression bug fixed gen expression bug. I think that's good enough. Bruh, did I not? Bruh, I swear I put my token in, bro. Why is it asking for this now? Alright, guys, hold on. I swear I literally just made a token for this. And it was like, okay, you're good, G. What? And I don't even have it open on GitHub anymore. Great, I have to make another one. Ugh. I have to make a new token, guys. Great. Like, come on. Lock in. Oh my days. I have to like click every single button. Bruh. I don't know how to set my GitHub token. Really? It didn't copy and paste? Really? Dude, I hate Windows so much. What the? Chat, it did not. Hmm. Oh my gosh. Let's let's just try this. Why is it on? Bro. Alright, I'm just gonna try this. Dude, there's no way I have to do that every time, bro. Can I just do this so I don't have to... Okay. Alright, that's fixed. Jeez Louise, man. Let me close this, too, so I don't leak my token. Dude, I hate, like, I had to go through Stack Overflow just to figure out, like, I hate everything, okay? I want violence! Like, it's too much, man. It's too much. I had to make a new freaking authentication token, dude. This is too much, man. Alright, we fixed one bug. That still doesn't really get us anywhere. I don't... So, let me go back to this. Let's see. So, hold on, chat. I'm gonna go potty break, chat. Potty break. I'll be back, chat. 1 sec. And then we'll continue programming. All right, chat. Oh, a little too loud. All right, we're back. All right. Let's see. I don't really understand how like this works. So we still need to make a break. I knew this was gonna be a really difficult thing. Actually, you know what? Let's just add division support before we do anything. Uh, let's just do division before anything. I feel like this is gonna just be way more easier than to freaking. The issue with LLVM is that it's so like their documentation. It's kind of abstract. Like it's really abstract. Like what the hell is UDiv? It's not like yeah the definition is here. It's like yeah, I guess you have to like RTFM, right? What line did it say? But like what like there's different kinds of divs, like division operators. So like what the hell is a exact UDiv? What the hell's a SDiv? Like as like a hobbyist programmer, it makes zero sense to me because like when people say RTFM like and then you do try an RTFM, to me like I have no idea what UDiv means. And like even though like I'm like trying to make my own compiler, and this is not really helpful because like I'm pretty sure that like this has something to do with like floating point or something I don't even know. Like I have zero clue what it is. Like what the hell's the exact SDiv? What is that? It doesn't make sense to me. All right, like create add like that's like obviously like self-explanatory, but like then you get into like NSW add. What the hell's an NSW add? All right, so let's Google this. Let's go on. Let's hop on a Chrome real quick. Let's use Chrome. What is a NSW add LLVM? All right, so like you look it up. Okay, well the AI overview kind of gave it to us, but like then you got to go over here and it's like well like the docs should be self-explanatory. I shouldn't have to hop on freaking Google Forms and just like look at this. Like it's kind of ridiculous. Maybe I'm just like a really bad programmer and I don't know the like what NSW means. But now I get no signed wrap what it means. So uh like okay, let's read. I'm trying to understand the semantics of LLVM. Like based on my understanding, language reference management, I think they're different. YG add 3 as redundant and deleting it. Your views on their common domain, the two instructions coincide, but the second one is defined for more pairs of input. That is, it's also defined where signed some overflows. So it's correct that the first one is redundant in favor of the second, but not the reverse. Didn't really help me explain what NSW is. The language manual says NUW and NSW stand for no unsigned wrap and no signed wrap, respectively, are keywords that are present. The result of the value. Okay, I think I understand. So I guess it doesn't. Does it wrap or does it wrap? The result of the value of add is a poison value if unsigned or signed overflow respectively occurs. So I'm guessing it would like leave a certain value if there's a overflow. I don't know what a poison value is. What is a poison value? What the hell's a poison value? Okay, so yeah, so it basically leaves like not an error, but it kind of explained it in the AI overview. But like if there is a signed overflow or unsigned overflow, this I'm assuming we'll leave a poison value. It's really hard to understand the docs, at least from like what I'm reading. Maybe I'm reading the docs wrong. Maybe I'm doing something wrong, right? Doesn't really make sense to me though. Let's continue. So if I want to add division, let's visit udiv. Uh, what is udiv? What the hell is that? What? Whatever. What is udiv? Udiv is an instruction that represents unsigned integer division. Okay, so like now it makes a little sense. Okay, I get it. Okay, so in our case, we're going to be using udiv because, actually, I want to see something first. So in our case, we are going to be using udiv because integers in my language, at least for integers right now, we're just going to implement integers and then we'll implement floats later. But for just ints, it's going to be integers are represented kind of like in any other language. This is going to be an unsigned 32-bit integer. I think it's 32. I don't know. So we're gonna have to use udiv though, I believe. And then for like I guess hold on, I'm getting another text. One. Sorry. Oh, I'm okay. Oh, sorry. So yeah, so we're gonna use actually no. Sorry, I have a reverse. We're gonna use I think it's sdiv. We're gonna use sdiv because yeah, sorry, all ints are signed, so it can be negative unless my understanding of that's stupid. So we're gonna use create sdiv. All right, so let's implement that right now. So let's do. Also, I need to Google something else because I don't flame me for being a trash C++ dev. I don't know if float is. I would guess floats are signed. Okay, floats are signed. So we're just gonna use sdiv for float and ints right now. So that's all we're gonna use. So that's gonna be in the generator. That's gonna be here. Okay. This should actually be pretty simple. We'll just do this. Actually, I don't even know what my token is. Sorry. Okay. And then we're just gonna do a it was it s what was it? Create sdiv. Was it all caps? I don't remember. I keep looking back and forth. Okay. Let's see. This should be the same for our floating point types. I should probably add some like lines between these actually. Whoops. Div floating, and then up here. I don't know Vim keybind. I don't know too many Vim keybinds. Alright, guys. So like, don't flame me for not knowing how to put spaces in between different lines. Like, all right. Let's test this out though. Let's make sure this works. Create sdiv. Create. Oh. Oops. All right. Let's see if this works. So instead of this, we're just gonna do like divide. Actually, I didn't check something though, because this is an interesting point. Because can integers represent? I don't want to sound dumb. This is what I'm gonna do. This is what I'm gonna do. This is what I'm gonna do. We're gonna do C++. Okay, I forgot I don't have Vim on this. Booyah! All right. Int x equals 10. Int z equals x divided by. Or let's do 5 like we did in our example, and then we'll do x divided by 1. Because I don't know if this works. I don't like. Or how do I don't know explain. Like, will this work? It does work, and it does store it as an integer. That's interesting. However, I don't like. Would it be represented as a? Sorry for my misunderstanding. I'm trying to what I'm trying to think is because if you divide, an integer can't really be a decimal place, right? An integer type, so inherently. So what would this output actually be? So I want to see this actually. So we're going to do a test.c++. Just I just want to see this. I know I'm not using std mline. I just usually do that in this instance. I want to see what this actually prints though. 2. So what if this was like 3? 3. So does it just drop the remainders or the decimal? I think it does. Let's Google this. This is like testing my basic C++ understanding and programming understanding, and I look like a complete noob. But I'm really trying to understand this as on a lower level. So does dividing two integers remove the remainder C++? This is like a really basic question that you should know. Should be able to just use it. Modulo. I don't think this is that's not the right question. Okay, so it does. Okay, it gets truncated. Okay, that was like a really noob moment. Like I should have known that. That's really interesting though. I guess it's like a. I guess that's not really like a. I'm not gonna talk too much then. But I'm guessing it's different like on low level. But let's see if Oops, unknown character. Do I not have that support? Wow, I don't even have that supported in my Lexer. Okay. Do I even have div equal? Does div equal even exist? Is that a thing? I'm sorry guys, I feel like such a noob right now, but if I did whoops. guess that's a thing. Div equal. Do I have that in my Lexer definition? Let's see. Okay, I do. Like, I don't use this like kind of stuff like on the daily, so I kind of look like a noob right now. But if we make this, it should Lex properly. SDiv. Okay, let's make sure everything's right. So we allocate store 32, 10, 5, load that into 0 and 1, and then do an SDiv. And then store the value. I think. Am I creating a load when I do this? Like, if I do. Do I create a load? When I generate primary expression, am I doing a load? I am making a load. I feel like this is kind of like. Is this useless? Because I could just do it directly onto. Let me see. No, it does create loads. That's really weird. But it passes the numbers to it though. So LLVM, like if because you could when you do like these create kind of things, like these create operations, well, like variables, you could decline like these percent signs. These are variables basically. You can declare your own variables. Obviously, what I'm doing because I'm passing it to LLVM and it says, okay, this is a variable. It's a little more verbose and it's a little easier to debug that way. But by default, it'll just do numbers, which I don't like. I don't like how this looks. But then again, I can't really have the same variable name and doing, I guess, defining a different. I guess this makes the most sense because then LLVM will handle it for me and I don't have to worry about other nonsense code. I guess for now we could just have these be numbers because this is still verbose enough to like where you understand, like if you're looking at the IR, you're like, okay, this is a variable y holds the value 5, right? So but I don't know. I guess you technically you could change that if we come down here, if my generate statement, because I kind of passed the name here. Yeah, see, so I pass the name here. When we make a new global variable. Wait, what? No, it shouldn't be it's a local variable right here. So when we create a store, yeah, we pass the identifier here. Wait, is this right? No, I'm trying to read through this. I don't think this is a global variable. I don't like how I have this else. It's not like you can't really tell what's going on. You kind of have to like scroll up and see like, oh, if handles global variables, local variable. Create alloc a. Okay, whatever. But yeah, so we passed the value here. So if we didn't pass this the variable name, it would just be 0. I don't really. That's kind of like a waste of time to prove it, but we have division added. Let me try doing it on floats. I'm actually kind of interested to see what the result would be. Also, another weird thing I found. Oh wait, what am I doing? What am I doing? What am I doing? I'm geeked. I'm geeked. Whoops. Whoops. How do you, how would I do it to where I could just do... Hold on, I'm trying to, like, remember my Vim. It's Shift-I. There we go. I remember. Yeah, there we go. I don't know why I just made it again. So I think something there was an interesting thing that was going on to where it was like pre-computing it. I don't know if that was my fault or if that was LLVM, if that was like LLVM backend doing it, but like I would see the actual value like be passed, which is very weird. It was really interesting, but because Because when you compile it, once you actually compile it, then I guess optimizations look at it and it's just I don't know. I really don't understand. Maybe I thought of it incorrect, but like when I did this, or maybe I could do it like if I just did. It might actually do it if I do 10 divided by 5. Let's see. No, it didn't. Let me make sure. Oh wait, no, it did. See, it's really weird. See how it stored 2? I don't understand. Like why? This like bothers me. I don't know why it pre-computed 2. Because it's not an optimization of mine. It didn't like. This really hurts my head. Let me let me go to the generator and see. Because this would go to this would generate the binary expression here. Gen binary expression. So we're dealing with division between two no, it'd be this. It'd generate the left side first. Wait, what? No, it would do this. It would do this. It would realize it's sub, and then it would create. It'd create a div, sdiv. This hurts my head because if we pass values, it doesn't create a load, which it's so weird. It just does it for us. Like if I did put 3, if I put 3, I'm pretty sure it would. Pretty sure it would work. Wait, this is also weird because floats are decimal points. Oh, I think I have to use a different. I think I did it wrong. Like if I did 3, will this keep the remainder? It doesn't keep the remainder. Our floats. Wait, what? I'm so confused. Why does it do it? Okay, so we're working with here. We create a sdiv. I don't know why it calculates it though. Why does it just store 3? That's so weird. Let's also why does it put in a integer 32? It should be what? Why is it putting into I32? It just calculates it. It doesn't even do the div instruction. It just calculates it. This is hurting my head, guys. It's really hurting my head. Why? This is a float, and then it decides to store an I32 in the float. Am I doing something wrong? This hurts my head, guys. Okay, I think maybe this is a bug that like we need to fix. Maybe we need to tackle this. This hurts my head. Let me just make sure I'm not. Let's look at the different divs though. Exactdiv, sdiv, udiv. What is exactdiv? You know what? We're just gonna do the method of doom. This is what we're gonna do. The method of doom is this. We're just gonna do every single div until we get the result we want. So we're gonna do exact. If exact is what I know or think, if it is what I think it is, it should just give us a decimal. Huh? Create exact div. Oh, udiv. Sorry. It's gonna be sdiv actually. Because floats are signed. Create exact sdiv. Okay. It's very interesting. Let's nope. And it's still storing what the it's still storing a float. I mean I32. Where let's go here. Let me go back to my let statement. because we create the stores here. Create store initial value. Oh, maybe we need to create a what? I-32. Alloc is. No, I think this is where I messed up. I think I need to add a separate thing here. Create store. And the value, the value is what we get from generating our expression. Create store. Is there different create stores? Let's see. Here. Whoops. Create store. There's only one. Because what we're returning is not an I-32. Generate expression. So that goes up to here, gen expression, which then turns into a this. Oh. Oh my gosh, I totally forgot how I implemented my own freaking language. I forgot how I implemented my own language. I defined floats as like a float value has to have a decimal point. Oh my gosh, that's such a noob moment. So then it stores the actual value. So I think yeah, so now it stores float, but I don't think this is the correct. I think now we have to change this. I think instead of create exact. Whoops. I think this is what this is estiv float. Okay, I think this is right. If I'm wrong, please make fun of me in the comments or whatever, or in the chat. Because like this hurts my head, guys. Ugh. So we had a division though. Okay. Well, we figured that out. I don't. This is weird. It's like one of those shenanigans again. Also, I don't think this is right either. Hold on. We're gonna ask ChatGPT. Okay, okay, never mind. It is done. I just closed our only. Okay. Okay, so I guess that works. The real question is though, how like that doesn't still solve our question. That it doesn't solve that like why it pre-computed 3. You know what I mean? Why is this like if I did int instead? This should actually throw an error if I'm smart enough. I guess it didn't throw an error. Okay. I need to make type safety in my language. Why does it pre-compute 3? Why? It makes no sense. Is my... like, this is like really testing my fundamental understanding of programming in every single way. So, okay, so if we go here to integer, create sdiv. Sdiv should be called. So we get to here, sdiv is called, and the result... Let me see if does sdiv just pre-compute it for us? Because I don't understand why. Create sdiv. Create sdiv. Where's sdiv? Create sdiv. Okay. It's right here. It inserts binary operators though. If value, return value. What? Fold exact bin up instruction is exact return v. Oh, I think this actually pre-computes it here. And then it returns the value. I think. Because otherwise it doesn't return, it doesn't, fold exact bin op. Binary ops. Oh. That's the only reference? What? That can't be right. Instruction sdiv. Does this like, is this like a pre-optim? This is .h. I want folder. I don't want .h. I want the actual code to this function, dude. Fold exact bin op. What is fold exact bin op? Oh my gosh, this is what... Let's just... Is a virtual method class used for constant folding a binary option? Okay, so that answers my question. So LLVM does do a pre-optimization of our code. Or not even an optimization. I guess it's just, it just does it. Okay. Well, that's cool. So that explains why instead of actually doing the sdiv, instead of inserting here, so instead of adding the extra instructions to actually run it, it just evaluates it at compile time, and then it gives it to us. That's actually pretty cool. And we figured that out by reading the docs. So reading the docs actually it teaches you a lot about a language, and like a API, I guess, or in this case LLVM. So RTFM, you know, even though the docs are hard and you may need to Google a few things, but that's interesting. So what it does here is it actually does an if statement. It sets v, it sets the value to this, and then it runs the fold exact bin op instruction, and then it sees if it can compute this, and if it can't, it's just going to insert a binary operator between our two values, which is left hand side and right side. Otherwise, it's going to do no, not otherwise. That's it. It's just gonna create sdiv. And then but yeah, if it can pre-compute it, it'll try using this fold exact bin op. Fold exact. The only issue is like with this is like that I could possibly see is that like if you actually want the instruction in there, this is kind of like it's like an optimization. and you can't really like turn this. You can't really turn it off unless you just go into the IR Builder source, right? The IR Builder class, and then remove this line of code, and just return this instead, right? But that's really interesting. That's I was always wondering. I never read this kind of like I never read the code, but I was like I always saw like it would insert the calculated value, and I was like, why is it inserting the calculated value? But now we know it actually computes it. That's very interesting. Very interesting. Uh, it's interesting, but I don't know if that's a good design. If that's good design because it's kind of like a optimization, and like you now I can't really control. But I guess maybe it's like a bare bones optimization that nobody really cares about. Like I wonder if I did this, if I turn optimizations off, right? I think that's how you turn optimizations off. And then I did like, oops. This should still give us like the load. It'll just load it first, right? Yeah, it doesn't do the actual thing as we see here. But if we did like, if we used a different compiler like GCC, let's see. This is like this is also a great example of like how different compilers do like how different compilers work. Let's see. I think I just skipped over it actually. I think we just use this. Okay. Like if we come down here, let's see. Without the compiler flags. Huh. I guess it does pre-evaluate it too. I guess GCC does that too. That's interesting. So now you know that like your compiler is like, oh wait, if I did O0, will it do it? No, it still does it. So that's interesting. So in my opinion, that kind of looks like an optimization, right? Because like it's like you're just gonna compute it at compile time. That's it's very I guess this is like a prime example of how compilers work, right? Like we are seeing a prime example of how a compiler works. Anyways, let's go back to LLVM now, or Clang. Just so we could see. This is also very different code. Whatever. That's very cool. Very interesting stuff. So now we just learned something that LLVM will pre-calculate the values for us. So now we have the division. I think I'm honestly gonna take a break here. I do have some other stuff I want to get done, but we did add division support for our language. Even though I'm not a fast programmer, like usually I'm faster than this. This was kind of like, how long have I been streaming for? An hour and 24. So it's like an hour and 24 just to get myself more familiar with my project. It's been over 3 months since I last worked on this project. So I just had to get myself familiar. And we learned a few things. We learned that LLVM will actually try and pre-compute some stuff if it can. So yeah, that's about it for the stream. I will be a little bit faster in my programming next time, obviously. I think we should. So what we have to do is also before I finish this, let me remove build, git add, git commit. Added division support for both int and float types. That just got rid of our build stuff. We didn't need that. This repository was moved. Did it actually get pushed though? Am I on the right branch? Let me make sure I'm on the right branch. Okay, it was updated. And let me make sure. Okay. So let me actually make sure like the code is like good. Let's go to. Yeah, I'm kind of weird about this stuff. Like create SDiv. Okay, okay. So all our changes were saved. All right. Thank you for all who are watching this on YouTube. If you're not here live, tune into the live stream. I'm actually gonna start doing some cool stuff. I might do a crypto giveaway. For people who like clip and who are just like into my community. So yeah. Thank you guys for watching, and I'll see you guys later.